Okay, welcome back. Many of you might enjoy eating vanilla ice cream. The flavour of vanilla comes from vanilla beans, and one of the flavour components of vanilla beans is the organic molecule vanillin. It contains three functional groups: an aldehyde group, a hydroxyl group, and an ether group, which is a carbon single bonded to an oxygen and single bonded to another carbon. The functional groups present in vanillin, there's three functional groups, and vanillin is an organic compound because it contains carbon and it's not a carbonate or carbon dioxide. So in this lesson, we're going to look at part 2 of the structure of organic compounds. So we're going to look at primary, secondary, and tertiary alcohols, aldehydes and ketones, carboxylic acids, and non-branched esters. So alcohols. Alcohols are derivatives of hydrocarbon that contain a hydroxyl functional group, or an OH group. There are 3 types of alcohols that you need to be aware of in the VCE Chemistry study design: primary, secondary, and tertiary, which are often written as 1 degrees, 2 degrees, 3 degrees for primary, secondary, tertiary. A primary alcohol, the hydroxyl group, which is the functional group, is bonded to a carbon atom that is bonded to one alkyl group. So this is our alkyl group, and the carbon is bonded to one alkyl group, the carbon that contains the hydroxyl group. So this is a primary alcohol. It's the OH group, or the hydroxyl group, is on a terminal carbon. A secondary alcohol has a hydroxyl group that is bonded to 2 alkyl groups. So this is alkyl number 1, and this is alkyl number 2, and this is our secondary alcohol. Primary alcohols and secondary alcohols are both quite reactive. Tertiary alcohols have 1, 2, 3 alkyl groups attached to the carbon that's got the hydroxyl group attached. So this is the tertiary alcohol. And tertiary alcohols aren't very reactive because of the presence of those alkyl side chains. So they're very stable and quite unreactive, which we'll come back to in later lessons. Now, an alkyl group is a group that contains only carbon and hydrogen atoms, and they're derived from the alkane series. So a CH3 group, if these are hydrogens, this would be a methyl group. So it's like methane, we take off one hydrogen and we've got a methyl group. Okay, let's look at a worked example. We need to classify this compound. Now, this is written as semi-structural condensed formula. Let's draw the structure to make it easier to see. So we start off with the first carbon, and it's bonded to 3 hydrogens. So that's our methyl group. Then there's a carbon that is itself bonded to 2 hydrogens. Then we have carbon that's bonded to a hydrogen. That's the next part. But then to an O and an H. That's the hydroxyl part. And then a carbon that is bonded to a final methyl group. So if we have a look, we've got the hydroxyl functional group. So this is an alcohol. This particular alcohol, we've got a carbon chain length of 4, which is a bute. We've got single bonds between the carbon atoms. So it's an an, and it's on the hydroxyl group is on carbon 2. We count so we have the smallest numbers. So this is butane 2-ol. But we'll look at naming in a later lesson. So it's an alcohol, but there's one alkyl group here and a second alkyl group here. So there are 2 alkyl groups bonded to the carbon that contains the hydroxyl group. So this is a secondary alcohol that we can write as 2 to the 0. Okay, next we're going to look at aldehydes. An aldehyde contains a carbonyl group And a carbonyl group is a carbon double bonded to an oxygen. And carbonyl groups appear in many types of organic compounds. So an aldehyde contains a carbonyl group, but the carbonyl group is on a terminal carbon. So in this case, the carbonyl group is what we call CHO. So it's got the carbonyl group here, but it's also got a hydrogen because that carbon is a terminal carbon, and we write that as CHO. Now, be really careful not to confuse CHO with COH. COH represents a carbon bonded to a hydroxyl group. CHO represents an aldehyde. The CHO is the functional group, and it's called an aldehyde functional group. So here we have the CHO bonded to the rest of the molecule. That could be an alkyl chain. Here it's just bonded to the R is a hydrogen atom. This here is methanol, but we'll look at naming more closely in the next lesson. And just remember not to confuse aldehydes with alcohols. Ketones also contain the carbonyl group, but the carbonyl group is attached to two other alkyl groups, R1 and R2. R1 and R2 can be the same or they could be different. So importantly, the carbonyl group in a ketone is attached to a non-terminal carbon. So the carbonyl group is somewhere in the middle of the molecule. In a ketone, the functional group is the carbonyl group, but it's called a ketone functional group when it's present in a ketone. And then we've got the rest of the molecule. So this is the ketone functional group present somewhere in the middle of the molecule. Here we have an example. This one is propanone. The known part, the one, is telling us we've got the ketone functional group in the molecule. And we'll look at naming a bit later in another lesson. Carboxylic acids contain a carboxyl group. Now, the carboxyl group actually contains two other parts. It contains an hydroxyl group and a carbonyl group, all bonded to the same carbon. So the functional group is the carboxyl group, and it's abbreviated as COOH. This one here, we've got two carbons, carbon number 1, carbon number 2. This is ethanoic acid, but we'll look at naming in the next lesson. So importantly, as far as reactivity goes, this hydrogen atom in the carboxyl group is acidic. That means that carboxylic acids are weak acids, and we know acids react with bases. So carboxylic acids will also react with bases. The carboxyl group can bond to an alkyl group, where R is the rest of the molecule, or to a hydrogen atom. And if this was a hydrogen atom, this would be methanoic acid. Did you know that when we get to naming, the carboxyl group has a higher priority over any other functional group? So it's automatically infers that the carbon that's part of the carboxyl group is carbon number 1. Esters formed when alcohols react with carboxylic acids, and many esters have fruity type flavours about it that contribute odour and flavour to food. Now, esters contain a C double bond O, and then the carbon with a single bond to another oxygen, and then a carbon. So it's this COOH group. This is the ester functional group, and we'll look at how to name esters in the next lesson. So this R here is actually the carbon that's attached to the rest of the molecule. Now, in past exams, VCA accepted COOH group as an ester functional group, but that's a little bit misleading because the COOH group appears in COOH, which is a carboxyl group, and in some other functional groups. So it is better to write the COOC to identify the group as an ester functional group. Let's look at a worked example. This structure is ethyl butanoate, and we'll look at naming in the next lesson. And the structural formula is shown. There's a number of parts to this question. First of all, draw the semi-structural or condensed formula, then the skeletal formula, then the molecular formula, write the empirical formula, and circle and name the functional group in the structure. So if we have a look, we start off with a CH3, then we have a CH2, followed by another CH2, followed by our kook group. The second carbon is bonded to 2 hydrogens, and then we have CH3. So that's one way we can write our semi-structural formula. The other thing we can do, and both of these versions are correct, is we can say we've got CH2 twice, and that's inferring it's in the length of the chain. So either of these is acceptable. So either this or this. From our semi-structural formula, we can start then or directly from the structural formula, we can start writing our skeletal formula. Now, the skeletal formula doesn't show carbons and hydrogens that are attached to carbon atoms. So this vertice infers there's a carbon here, and then another carbon here, then another carbon here. Then this would be the carbon that's part of the double bond to the oxygen, then a single bond to this oxygen, then another carbon here and another carbon here. And we omit the hydrogens that are bonded to carbons. So it's inferred that this is CH3. So this is the skeletal structure of this compound. So that's worth 1 mark as well. So semi-structural 1 mark, skeletal structure 1 mark. If we count up from either our structural formula or our semi-structural formula, if we count up the number of atoms of each type, we get the molecular formula, which in this case is C6H12O2. We can halve that. We can divide that by the smallest number, which is 2, and we get an empirical formula that has a different formula to the molecular formula. Sometimes the empirical formula is the same as the molecular formula, but in this case it's different. We can get our structure and circle the kook group, which is the functional group, and we label that, so that's circled. And if we label that as an ester, then that's our labeling and identifying the type of functional group. And we also wrote the molecular formula. So we've shown all of those parts to the marking guide. Okay, a mega question activity for you. Classify this molecule. Have a go at this question. Okay, this is an aldehyde. It's not a carboxylic acid. We would expect a carboxylic acid to have OH coming off the same carbon. It's not a ketone because we would expect the ketone to have a carbonyl group somewhere on an internal or non-terminal carbon. It is an aldehyde because it's inferring that from this carbon, there's also a hydrogen there. And it's not an ester. An ester has got a carbon double bonded to an oxygen with another single bond oxygen coming off the carbon, and then a kook. We don't have a kook here. So the answer is C, aldehyde. Okay, so we've learnt more in this lesson, and I would encourage you to put this onto cue cards so that it becomes like a language for you. A primary alcohol has a hydroxyl group on a terminal carbon. A secondary alcohol has a hydroxyl group attached to a carbon that is attached to 2 alkyl side groups. A tertiary alcohol has a hydroxyl group attached to carbon with 3 alkyl side groups, and tertiary alcohols aren't as reactive as primary and secondary alcohols. An aldehyde has a CHO group on a terminal carbon, so it's got a carbonyl group, but we actually write it as CHO. A ketone has a carbonyl group that's on a non-terminal or internal carbon. And ester contains an ester functional group, which is a carbon double bonded to an oxygen, then single bonded to another oxygen, and continues with another carbon. A carboxylic acid has a carboxyl group on a terminal carbon. A carboxyl group is a C double bond O, and then an O, and then an H. Structural formula shows all atoms and bonds. Semi-structural formula shows all atoms. Skeletal structure shows a carbon backbone as vertices. Non-carbon and hydrogen atoms are shown. It assumes that other atoms are hydrogen. The molecular formula shows the number and type of atoms in the molecule, and the empirical formula sometimes is the same as molecular formula, but the empirical formula always shows the simplest whole number ratio of atoms in a compound. Next up, we'll start looking at naming organic compounds. See you then. Bye.